Do you know how civil engineers design large projects? Let's look at the entire process of the engineering design work for a typical large-scale civil engineering project. Civil engineering is a very broad field that includes many engineering disciplines and types of construction. All common civil engineering projects fall into a few broad categories. Transportation projects, highways, roads, airports, etc. Water resource projects, channels, dams, dredging, water distribution systems, and others. Enviro projects, those are projects that relate to waste, sewage, pollution prevention, and drainage. Building projects, this group is self-explanatory. Underground projects, tunnels, collectors, sewer lines, etc. Land development projects, clear and grab, and geotechnical preparation for the future development. Examples of such projects include container yards, highways, bridges, maritime wharves, stadiums and arenas, schools, sewer stations, and many others. Keep in mind that each project requires a unique approach and design solutions. However, in a nutshell, any civil engineering design work would follow the very same basic engineering steps and only differ in detail or depth of certain steps. Before design work begins, certain basic input data needs to be collected by the engineering design firm. This data defines requirements for the project and is provided by the owner of the project. In addition, engineers obtain design loads and criteria, such as different specific dimensions that needs to be met, wind load, and so on. Finally, any additional owner's wishes are gathered. For example, the owner may request that all exposed steel must be galvanized. With this information, design work begins. This is where it gets a little complicated. Design work is separated into two phases. Field phase, where engineers assess site conditions, and engineering phase. This is an office phase, where engineers do all modeling, calculations, drawings, and other paperwork. First, let us cover the field phase. There are two activities that engineers need to do in the field: pre-design site survey and geotechnical investigation. The survey team needs to walk the future construction site and record everything in detail. All surface and visible underground objects are recorded, such as manhole lids or outfall pipes. Topography over the entire area is recorded, and pictures are taken. Surveyors are the eyes of the engineers. At the same time, geotechnical investigation begins. The main objective is to tell design engineers what soil they will be dealing with. During subsurface investigation, geotechnical engineers obtain samples of soil. Typically, drilling rigs are used to bore soil and recover samples for lab analysis. The geotechnical team will produce a formal report describing soil conditions and listing different soil capacities. Boring logs are also included in the report, so engineers can see changes in soil layers. This report will later be used by many other engineers as one of the inputs for their calculations. With preliminary field investigation completed, it is time to focus on engineering. There are two things that office engineers need to start doing immediately as work begins: utility investigation and permit applications. Those two activities are not exactly engineering work, but rather paperwork administration. However, it is very important administration. Without permits and clearance from existing utility owners, construction would not be able to start. In addition, existing utilities may significantly alter the design and placement of the foundation, as well as new utilities. Next, engineers do calculations, drawings, modeling, and determine appropriate design for each individual element of construction. This work is split into sections. Sections in engineering world are called divisions. Each division is developed by its own engineering group that specializes in that field. Each engineering group has its own project manager, who is responsible for overall design of the specific division. The principal engineer oversees all project managers and is in charge of the main decisions. So, what are those divisions? According to the Construction Specification Institute, there are 50 divisions that cover different aspects of construction, such as concrete, metals, wood and plastics, and many others. Let's take a look at the most common division groups that are used on most projects. General division. This is something like a foreword of the book. This division contains general comments, design remarks and requirements, and some housekeeping information, for example, laydown area or traffic control information. Civil divisions. These divisions include civil engineering work: demolition, water lines, sanitary sewer, utility crossing, striping, fencing, grading, shore stabilization, drainage, pavement, and many others. Architectural divisions. These divisions cover architectural aspects of any buildings that are involved in a project. Structural divisions cover structural details of the civil and architectural divisions. For example, the civil drawings may show that a light pole is needed at one point. Foundation details for the pole would be in structural divisions. Manholes may be required here and there. Details for manhole construction would be in structural divisions. So you got an idea how it works. Next are electrical divisions. These divisions cover all electrical aspects: substations, power circuits, one-line diagrams, cable pulls, duct banks, light poles, and so on. And lastly, we have telecom divisions. Everything runs on the internet today, so all communication, cameras, and internet aspects are covered by these divisions. Engineers pick and choose divisions based on the needs of the project. Design is not done all at once. The principal engineer is in a constant communication with the owner in case any questions or issues arise. Throughout the design process, engineers also hold formal meetings with the owner, usually at 30, 60, and 90% intervals. During each review, the engineering team presents calculations and findings to the owner. Feedback and corrections from the owner are taken and implemented. After all meetings and implementation of all changes, a 100% final design package is delivered to the owner. So, what do engineers deliver as all investigations, calculations, and design are done? There are several deliverables that are provided to the client. First, permits. All permits that are required by local authorities, city or county, are paid for and acquired by the engineering team and are delivered to the owner. Second, drawings. Drawings would outline the entire intent of construction, list all details and requirements. Contractors will be using drawings as blueprints for estimation and execution of construction. Reference drawings, if available, are also included at the back of the drawing set. Next is technical specification. This document lists details of all standards that must be followed, requirements for materials, and testing of the materials that will be used in construction. In a simple perspective, drawings show what to build. Technical specification shows which materials to use and what standards to follow while building what is listed in the drawings. Next document that is delivered is called the basis of design. This is where all modeling and calculations reside, along with all investigation data that calculations are based on. Finally, estimate and submittal log are provided. An estimate would tell the owner the expected exact cost of construction. Submittal log is list of documents that contractor would need to submit for approval prior to construction. Some other documents may be included on as-needed basis. When deliverables are completed, the owner is ready to put project for a bid and get contractor aboard. At this point, the work of engineers is not exactly over. As project will move into construction phase, engineers would be reviewing different documents that contractor would be submitting, as per submittal log. But that is a story for another day.